Alright students, in this video we're going to be talking about the tangent ratio. Tangent ratio will be the first of our trigonometric ratios. And what a ratio is just a fraction. Okay, so ratio compares two things. In a classroom you might talk about the ratio of students to computers. How many students per computer, or how many computers per student. That would be a ratio. You could also talk about ratio of males to females, sophomores to juniors. In cooking, a ratio of oil to water, a ratio of sugar to oil, whatever it is, it's a fraction. Okay, so we've seen those before. In the tangent ratio, it deals with sides of the triangle. Let's write that out. And the ratio is the tangent of the angle A is equal to the opposite over the adjacent. What does that mean? What that means is if we measure this, and let's say we took our ruler here and measure that, I'm just going to make it up. Let's say it's 3.5 inches. And let's say this was 8.2 inches. The tangent for A would be 3.5 over 8.2. Now, that in itself is not very useful. You'd be like, well, why would you use that? Well, here's what we can do. We can change it into a decimal, and that's about 0.42. And here's the deal. There's only one triangle in the world that has one angle in the world that has a 0.42 ratio for the tangent. And what it is every triangle that's possible was drawn at some point, and they figured it out and put all the values into a table, and we now have all that information stored in the calculator. Okay? For now, we'll just talk about that's what the tangent is, and we'll use that. But again, how did they get that? Let me show you. So someone would have drawn at some point, a 10-degree angle using a protractor and measured very accurately the ratio of those two sides. And then you'd write what the tangent of 10 was, and they put that in the table. Then they cranked it up to 15, measured the two values, and then had a ratio for the tangent of 15. Then they cranked up to 20 degrees. I quickly drew these, but if you drew them very, very accurately, if we used a protractor to really make sure it was 20 degrees, then we would have had a very accurate measure for 20 degrees. Now, you'll see this a lot in calculus, so the calculator knows this to a lot of degrees of accuracy, and that's how this is very useful for us. Okay. So, let's go back to this ratio here. Let's say we didn't know the sides, but we knew one of the angles. Okay, one angle on one side. And how this is useful is, let's say this is a flagpole. Now, it's not easy to measure the height of that flagpole, but it is easy to measure the distance. So let's say like this distance here, let's say this is the shadow, and let's say right now it's casting a shadow of 25 feet, and you looked up towards the top of the flagpole, and from the ground you saw there was a 18-degree angle. Let's find out how tall that thing is. We have all the information we need, and we're going to set it up right now. And the key thing about this is Pythagorean theorem would not get us there. We cannot do this with the Pythagorean theorem. We need the tangent ratio. And what we do is we say tangent of 18. Now go ahead and pause that right now and set up the ratio and see what you think. Alright, did you write h over 25? If you did, you're correct. What is that? Well, we're trying to find out what the height is. So, to get the height alone, we're going to multiply both sides by 25. Those will cancel. And you'll get this. 25 times tangent of 18. Again, I don't know what tangent of 18 is, but it's on the calculator, and in the old days you would have looked it up in the table, and there it is. You get 25 times tangent of 18. It's about 8.12. Alright, that is the height of our flagpole. Alright, well thanks for watching, and check you out next time.